Hello, my name's Fernando, and I'm a technical marketing manager here at GitLab. And today I'm going to provide two different videos, this being the first, which focuses on the 5 areas for GitLab compliance. And I'll go over what these features mean and how they are used within GitLab. The first one we're going to touch upon is the different security scanners that GitLab offers in order for us to achieve compliance and find what is vulnerable within our system. And if I look at the pipeline that just ran, you can see that all my security scanners run just how I defined them. Within the build stage, we build the actual application container. We run all the scanners, which were enabled just by adding those templates. We deploy to a staging environment, and then we run Dast, and then we can check out our changes within our staging environment. And the one way that this is useful and that these scanners are useful is if we actually go to a merge request, and let's say we have a merge request which introduces some vulnerabilities. Well, we can see that with our license scanner, we're going to detect some vulnerabilities here and show which licenses are actually present. And you can see that there are licenses that are present, but they're actually being blocked, and we're not allowed to merge this because they go against our policy. And we can see the same thing with our security scanning. So our security scanners run and they detected a whole bunch of different vulnerabilities, and these vulnerabilities are separated by the scanner and then by the severity. So you can see that what happens here is I can see that, let's say, memory limits should be defined on each container. So this is an example of infrastructure as code scanner vulnerability, and it shows that we don't have any limits on our memory, meaning that our container can just actually run out of memory and die that way, and it's susceptible to DDoS. So it tells us exactly where this occurs, and it can give us more information on the links on how to actually resolve this and how to actually assign memory requests and memory limits to our container so it'll enable us to prevent these vulnerabilities. Now we can actually continue to work on this, solve this, and then what ends up happening is if we can continually iterate and remove all the vulnerabilities that we can, and then after that relay it off to the software engineers that are within security, within the security team, for them to actually verify this code, and we can reduce it. And the reason we want to do this is because there are less security engineers than there are developers. So the more developers can fix on their own, the more it allows security engineers to work on what they do best, which is ensuring the security of the system, and they don't have to go back and forth continuously to do this. Developers can also dismiss the vulnerability with a comment and let the security team know that this is not a valid vulnerability, this may be only in test, and then when a security team member does a review, they can take that into note. So it really drives efficiency to developers and the security team. And you can see this is true for all the different scanners of different scanner types, and depending on the actual scan, you can see that there could be more information. This actually sends requests in Dast, so there's information on how to resolve it, links, what URLs are affected, here's the solution, and the same thing can be done. You can dismiss it or you can create an issue. This is true of all the other ones, so that way it'll create a confidential issue where developers and AppSec engineers can work together on a solution without alerting, malicious actors, without letting them know. So it's a great way to perform a fix if you can't fix it right away. It's a good way to keep that information and continue to iterate on that. So now that we've gone over the results provided by the security scanners, how does that tie into compliance? How do we enable that separation of duties? Well, the way that that's done essentially is using policies. So we can see here that we require 2 approvals from vulnerabilities detected and restrictive licenses detected. So these are policies that are set that are going to require approval from a set of individuals that we define if there are any vulnerabilities detected. And these can be very granular. They can, and we'll show you those rule sets next, but we can have different members of different teams require approval from them for different types of vulnerabilities. You can say, for example, certain people must approve container scanning vulnerabilities, certain people must approve dependency scanning vulnerabilities. You can also say things like, maybe the security team can approve anything that's low or medium severity, but maybe the team lead can only approve vulnerabilities of severity low or medium, but maybe we need the security team to approve vulnerabilities of high or critical, and that in that sense. And these are all very granular and can be chained together. Same thing for licenses. If we detect any restrictive licenses, we can say, let's allow all licenses except MIT. Let's deny certain licenses. It's very flexible with the way we can create these policies to enable separation of duties. And the way that that is done is by going to Secure and Policies. You can go ahead and we can create a new policy. And first, I'll show you the scan result policy that allows you to require approval. But essentially, what you do is you give it a name. So let's just say low, medium vulnerabilities. And then what we can do is we can select when a security scan for all scanners runs against all the protected branches, default or specific branches, let's just say all protected, and finds any amount of vulnerabilities with the following criteria. We can set an amount, but usually it's best to just say any that align with the following criteria, and we can say a new severity, and we can say low and medium. And then from there, we can require approval from individual users, certain roles, or we can say groups, and then here we can put members of the team that are team leads, or vice versa, or we can just say individual users and then just add, let's say, our team lead here. Let's go. And then we configure that with a merge request, and we can continue to create a bunch of different policies that will apply to the project. Same thing can be said for licenses. So let's say we want to do license scanning. We can say any newly detected licenses that match a certain license type or that are accept a certain license type. So that way we create a policy around the licenses that are allowed in the system or disallowed in the system. And then we can do the same thing. We can require approval by individual users, groups, or roles, and we can require a certain amount of approvals, let's say. The next policy is scan execution policy. And what this policy does is it forces a scan to run regardless of what the GitLab CI YAML file is. So in a typical workflow, developers can edit the .GitLab CI YAML file. But so meaning that they can remove a scan and then they can merge the code and then re-add the scanner, and then the policies won't be able to detect the change. Well, what we can do is we can actually go ahead and create this scan execution policy. And what this means is that we're going to run a SAS scan no matter what. And we're going to do it with runners that have a specific tag, or we can do it with customized CI/CD variables that we define if they're detected, or we can just run it off the bat without any options. And we can have it triggered by a schedule. So we have it run every day, every hour, whatever it is that we need. Or we can have it based off a trigger, meaning that anytime a pipeline is run on, let's say, the default branch, right, then that means that the SAS scanner will also run regardless of what the GitLab CI YAML definition file is. So these are a few ways to really enable that separation of duties and require outside approval if we detect anything. So that assures compliance in many ways. Every time that you create a policy in GitLab or you create multiple policies, they're always added to a security policy project. So a security policy project can have, X number of policies in it, and they can be applied to different projects or different groups. And what happens is that these security policy projects can have separate permissions than these projects here, which contain the actual application source code, meaning that developers cannot overwrite the policies, and that also further strengthens the separation of duties story. So now I'll show how we have an oversight of everything that's going on in the system. So what I do is under Secure, I can go to the security dashboard, and I can see the status of vulnerabilities I've introduced over a 30, 60, or 90-day view. And I also get a letter grade rating for my project. And this letter grade rating tells me A through F, like you saw in grade school. A projects are projects that don't have vulnerabilities. Then there's ones with low vulnerabilities, medium, severe, critical, and that's how they're rated. So you can see that there are critical vulnerabilities present here. And if I go back to, let's say, I don't know, my project, simple vulnerable notes, which has a whole bunch of vulnerabilities, I can also see this view for the project itself, and I get a 365-day view on when I've introduced or reduced vulnerabilities. So that helps me assess the security posture of my project. And for example, it tells me maybe I did a code refactor from this day to this day because I introduced a whole bunch. So it allows me to change my policies, my internal policies in ways that my organization does things so that way we can prevent vulnerabilities. Same goes for reducing. Maybe we had a hackathon here, bug fix, and we've reduced that. And we can encourage management to promote these type of functions because they are decreasing the amount of vulnerabilities. So same thing. Now let's say we want an additional oversight and we want to know what are the vulnerabilities within our system. Well, we have the vulnerability report, and this gives us an insight as to all the vulnerabilities in our system, and we can sort by the status, severity, what scanner was present. So let's just say SAST. We can sort by the project. So if I were just directly in the project, it would only show those things for the project. But if I'm in the group, I can sort by the vulnerabilities in the project. So if I go to, for example, let's just say notes, I'll find the simple vulnerable notes application, and I can see all the SAST vulnerabilities within there. Maybe I can lower it down to medium. And if I go down to a vulnerability, let's say the SQL injection vulnerability, I have a whole bunch of information on how to resolve the vulnerability. I know exactly where the vulnerability is located. I have identifiers such as the CWE, which gives me more information on how to exploit it and how to actually resolve it and how it affects my system. See the line of code where it's present. So you can see that this is where it's happening, where this query, understanding a SQL injection, it's telling me that I need to use a parameterized query here because this is what's causing additional data to be passed in as the ID. And what I need to do is I need to use parameterized queries, and what that will do is it'll allow a function not to be passed in as the ID. It'll clean out all the SQL commands and only pass in the variable. So there's also training here to better educate the developers. So there's a variety of different partners, and if you were to click on training, for example, you'll be sent over to the training partners info, and here you can select the different languages and go through different exercises for the SQL injection. And this enables developer learning and allows developers to learn how to assess these tools. There's also AI, so you can explain this vulnerability with AI, and once I click on that and try it out, GitLab's AI models are going to go ahead and use our code to then generate an explanation about it. So it's going to tell us what the vulnerability is and how it affects our system, how an attacker can actually exploit this and take advantage of this vulnerability, how it can be resolved, and then there's going to be examples of the vulnerable code here present. So, and it's going to show us what an example of fixed code is, how to fix it, and there's going to be references around that. And another thing that can be done within the vulnerability report is that the status can be set of either confirming, dismissing, or resolving the vulnerability, and I can apply that to alert other security team members of its status and change the status within the report. The next way that we can see what's going on is via the dependency list. And the dependency list is going to give us a full oversight of every vulnerability that our dependencies cause. It's going to tell us what is vulnerable, what packager it's in. Is it within a container or is it within our actual dependencies like pip or yarn or etc. what dependency manager we're using. And you can disable scanning the actual container images as well. We can sort by the severity packager component name. We can export this as a JSON or a Cyclone DX format SBOM within the job itself. And if we click on one, we can see the vulnerability itself. And if we click on that, we can go to the vulnerability page in the report, and then we can use this information to triage and resolve it. Then the next thing I wanted to go over are the audit events. So there's audit events for the project and for the group, and they give us information on what's being done in the system that could affect our compliance. So such as new members being added, permissions being elevated, tokens being generated, etc. So you can look at the documentation to see what is considered an event. So that way you can triage that, but you can also go from there and you can also stream these events. And by streaming these events, what can happen is you can use a third-party tool or create your own parser to then generate alerts anytime one of these events occurs. And then there's the one more that I wanted to touch upon, which is the compliance report. And what this compliance report does is it gives us places where we have compliance violations. And the rules that we currently have are less than 2 approvers, approved by the committer, or a committer, and approved by author. So those will flag that there is an issue of compliance with the way we are doing things. There's no separation of duties, so we can go through here and resolve that. And then we see frameworks, which I'll get into now. And what this does is it creates a compliance framework or allows us to apply a compliance framework to a project. And the way compliance frameworks work, if we look here, there's the compliance framework project. And so the way that it works is we define a project that contains a YAML file with a pipeline in it. And let's say this project only has permissions for our security team and compliance officers, so developers cannot edit this. And what this does is it has a SOC 2 compliance check job, which you can alter for your needs to achieve SOC 2 compliance. This is just a stub sample. And it includes all the stages that need to be run for the project. So NAD, SAST, and secret detection. So developers cannot change this. But developers have access to the actual application that they're working on, they're developing. So what they do here is they actually define the actual functionality for the application, but they're not working on compliance. They cannot delete compliance. They cannot change it. Their duty is to focus strictly on development. So here you can see that there are stages for getting the yearly income, getting the monthly income, generating the bar chart. And what happens here is that there's a label applied that says SOC 2 compliance test. So by seeing this, we would think that this is what developers can edit, and these are the only jobs that are going to run. But because we've applied this label, if we go ahead and check the latest run pipeline, we're going to see that there's SOC 2, there is the SOC 2 compliance, which wasn't part of our pipeline, was part of the other one, and there's secret detection and SAST. So this shows how we've enabled separation of duties because developers are only responsible for the application, and compliance officers in the security team add the compliance checks, which the developers cannot close and cannot do anything else with. And now the last compliance feature that I wanted to go over was the attestation. So it is the artifact attestation. And the way that this works is that by adding this variable here to your job, runner generate artifacts metadata, and setting that to true, GitLab is going to automatically create an artifacts metadata JSON that's going to have a hash of the actual artifact, in this case being poem.txt. And what we can do is we can verify if this artifact has been changed or tampered with by examining the SHA. So that SHA is provided by GitLab already. We can create an expected SHA of what we need, and then we can actually compare the two to see if we are in violation or not. So what ends up happening is, if we look at the pipeline, we gather the metadata. This is what GitLab provides in the artifact. So it provides the name of the artifact with its 256 hash. Now, this is a text file, so we'll note, we can easily see if it's been altered. But if this were a binary or some type of executable in that nature, we want to make sure that it's never altered. It's hard to tell without having a hash, so that's mainly its use case. And we can see that the job in the pipeline passed to detect tampering. But if we go to a merge request that actually changes the poem file, we can see that it's been tampered with because the actual hash is different because the file was changed. So in each project, you have different settings that you can apply to the merge requests, and you can apply different settings such as, let's see, merge checks, where pipelines must succeed, all threads must be resolved, status checks must succeed. So you add additional requirements before you allow things to be merged. And you can go down and you can check the approvals here, you can add more approvals, you can set up code owners, and you can set up certain approval criteria such as preventing the approval by author, by any committer, requiring a password for it, preventing editing and approval rules. And then you can, whenever a commit's added, you can remove all the approvals since it is a new commit and we don't know what's changed. And then there's similar things for adding compliance frameworks. You can change the visibility of the project and control who and what has access to what. So you can do that. And then in CI/CD, you can add further protections to that. So you can add protected environments. You can add secret variables that are protected, masked, or expanded. Secure files. And then last but not least, we have branch rules that we can add. So we can add different rules and on the branches, protect them, and we can alter the push rules of who can push, who can actually commit to the branch, who can force commit. So there's a lot of different rules that we can apply to the branches to ensure compliance. And what we can see here is that we can also have verified commits. So we can use a GPG key to actually have the commit as verified to make sure that the person that's committing is the person that they say that they are. So these are lots of other protections that can be added to your GitLab repository in order to assure compliance. Same can be done with code owners. You can give certain pieces of code, if they're ever edited, you can require review from certain members, you can require approval from certain members, and you can go through there. So those are just the majority of the GitLab compliance features. In the next part of this video, I will show how to set up these environments and clone them within your own workspace. Thank you for viewing, thanks for attending, and I hope you enjoyed this.